Okay, identify features of trig graphs and sketch a sine of nx and a cos of nx. So, we're going to introduce this idea of features, which just means, what does this thing look like? Okay, I've got my old graphs from last time, because they were so pretty that I just had to keep them. If we look at this, what can we say happens? Well, we can say this thing repeats every so often, and we can say, oh, it's all stuck between 1 and -1. Well, let's try to refine that language a little bit. Okay, so the first thing I want to talk about is what's called amplitude. The difference between the maximum and the center of a graph, or alternately, the minimum and the center, or alternately, the maximum and the minimum, and then divide that by 2. All of those end up the same, and I'll point out what I'm talking about. So let's take sine, the blue. Okay, I want the difference between the maximum, okay, the maximum is up at 1, and the center, well the center, the whole thing centers around the 0 line. So this thing's amplitude is 1. Great. Just to show that it's consistent, the minimum in the center, okay, the minimum is -1, the center is 0, so -1 to 0, how far away is it? It's 1 away, so same answer. Or alternately, maximum minus minimum. So we've got the maximum is 1, the minimum is -1, maximum minus minimum, keep in mind 1 minus -1 would be 2. Divide by 2 goes to 1 again. So no matter which way you calculate it, they're all the same. You're welcome to chop and change as you go. The idea is it tells us how much it moves away from the center. Great, so for sine, that amplitude is 1. And similar story with cos, since the whole thing's just shifted left to right, this direction didn't change, so its amplitude is also 1. Okay, great. What about the period? Well, okay, the period is, in a very loose way of saying, how long it takes to repeat. Okay, so if we take a look at sine, starts at 0, goes through 0, ends at 2 pi. So it takes 2 pi to repeat. Notice that just because it goes through 0 doesn't mean it's repeating, because here it's going up, here it's going down, so it hasn't repeated yet. So it goes through, and after this it'll start going up again, so now it's repeating. So the period is how long it takes to repeat. Beautiful. Similar story for cos. If I go from here, goes down, up, and up. This time it is repeating because the next thing it's going to do is go down, which is what that started as. So that's the period length. For that guy, it doesn't have to start at 0. In fact, one of the easiest ways to do it is pick the maximums and find how far apart they are. So here's a maximum for sine, here's a maximum for sine. So that distance across there would be the period length. This is pi on 2, this is -3 pi on 2. So pi minus -3 pi on 2 would give me 2 pi as that. And there's a bunch of different other ways, just like there was with the amplitude. You can chop it up however you want, but they all end up the same in the end. Beautiful. Okay, well, it turns out that this amplitude is the A that multiplies. Now, why does that happen? No matter what sine is, no matter what x value you put in here, ultimately everything's going to get multiplied by A. So the whole thing ends up A times taller and lower as well. So if I had 1 times A, it'd go up to A. -1 times A goes down to -A. So it all just stretches out, it dilates in the y direction by a factor of A. Beautiful. Now, because there's an n in here, you're going to tell me, well, the period must be n then. Unfortunately, not quite. So this is related. It turns out that it's 2 pi divided by n will equal the period length. Put equals in there, and equals in there. Now, why does that happen? The short answer is you can fiddle around to see it, but you've got 2 pi, that's how long it would normally take. If I multiply x by something, that means that x is going bigger, or in other words, it's going through the cycle faster. So the bigger n is, the quicker the cycle will end. So 2 pi is the normal cycle. If you make it bigger by a factor of n, everything will finish n times faster. So you have to divide by n to get the period length. If that's not 100% clear right now, don't be overly concerned. So long as you remember that the period is 2 pi divided by n, you'll be fine. Also, that means that n, if that's a fraction, then it actually takes longer to finish. So it's slowing it down, but if you divide by a fraction, that's what happens anyway. So it all takes care of itself. Cool, let's try to do some sketching. So I want sine of x times by 3. Okay, what does this do? Well, it's multiplying by the front, so it's an amplitude. So that tells me that I'm going to max out, oops, which colour? I'm going to max out at 3 and min out at -3. Great, okay, so here's my x-axis. That's supposed to be in the middle. Put this as my y-axis, great. Well, we know sine starts at 0, 0 and goes up. Brilliant. So it'll look something like that, and then it'll just keep going forever. Same on the other way, something like that. Great. We need a period length. The period didn't have anything multiplied by it, so well, that's just 1x then. 2 pi divided by 1, 2. So 1 period length here, down, up, would be 2 pi. Now I can fill in the rest of them as well, just to be a bit more complete. That would be pi. That would be 3 pi, because that gap should all be the same. I can say that's negative pi, this is negative 2 pi. Beautiful. So that's that, and that's almost it. The only other slight complications you can get are if you have negatives in there. So negative 3 sine, okay. I'm going to draw the same set of axes. Well, negative 3 means that you can think of it as my minimum is now negative 3. You can think of it as your maximum being negative 3, but you always draw it the right way around. So it's still 3. The only difference is now, well, everything would have been multiplied by a negative, so all your positives become negatives. So this guy flips over. So instead is now, ooh, I hope that looks okay. Ooh, it's not my best work, but I think you get the idea. In fact, that's terrible. No, I'm doing that again. It's still not great, but you get the idea. So on, so on, so on. Cool. Nothing changed for the period again. Great. So I'm here, go through one full lap. Okay, I'm going down again, so that's 2 pi. Cool, and we can fill in the gaps again. That's pi, that's 3 pi, that's negative pi, and negative 2 pi's over there. Now, if you're wondering exactly how far you have to draw, I haven't stipulated anything here. Typically, whenever you're not told, you draw at least 2 complete cycles. So I've got 1, 2 complete cycles there, that's fine. I've got a bit extra, nothing wrong with that. Bare minimum, you should be drawing 1 complete cycle, but usually you draw at least 2, like I've done up there. Cool, 4 cos of x. All right. So set of axes. Okay, well, amplitude is 4, so we max out at 4, minimize at negative 4. And cos is 3. Going to cos, notice that cos starts up at 1, so down, etc. Down, up, etc. These should all be the same height and the same width and everything, but I'm drawing freehand, so I'm going to have to deal with it. Cool. Period hasn't been changed, so 2 pi from maximum to maximum, so that there is 2 pi. So here, oops, change colour. Here would be pi, halfway in between there, that must be pi on 2, that must be 3 pi on 2, 5 pi on 2, and so on. You can fill them in as much as you want. Negative 3 pi on 2, negative 5 pi on 2, etc. Beautiful. Okay, negative and a fraction. No, we don't have to worry too much. So we've got a cos curve. It's negative now, so the whole thing flips upside down. Something like that. Cool. So now our amplitude is half. So everything got squished in. I'm not drawing these to scale relative to each other, by the way. If I was, this would be a lot squishier. In fact, let's do that now for consistency. So if that's 4, that's 2, that's 1, ooh, that's going to be pretty tight. I might draw it slightly out of scale, but still kind of a terrible straight line. There we go. So try to draw it close. So I'll say that that's about there, half, so that's about half there. Where are we going? Too early. Something more like that. is minimum? Is maximum about there? Something like that. So the half makes it a lot more squished. The negative means we flip over. So our amplitude, negative a half up to positive a half. Period length never changed, so it's all still the same. Get through one complete cycle there. So that's 2 pi. And we can fill in the rest of them as we see fit. Beautiful, okay. Right, now we're fiddling with the period length and not the amplitude, okay. So I'm still going to have the same basic shape, sine. Okay, great. So we're going to be going through this center. Ooh, that was bad. That black's dying a bit. Okay, great. I'm going to put a 0 line through there. So I've still got the same basic blue curve, goes up through there. Great. So that means that my period length should be 2 pi divided by that guy. 2 pi divided by pi. 2 pi divided by 2 is pi. Great, so that means it takes pi to go through a full cycle. That there is a full cycle. Cool, and then we can label off whatever we want. Pi on 2, negative pi on 2, ooh, that's bad. Negative pi on 2, negative pi, negative 3 pi on 2, etc., etc. And last bit is amplitude. Never changed. The basic is 1 because 1 times sine, so that's 1, and negative 1. Fantastic. Cool. What would this actually do? It means everything would happen twice as fast. Notice we went through a full cycle at pi instead of just 2 pi. Okay. More annoyances. Okay, cos. Well, cos is still the same basic shape. Something like that. We would normally start at a peak, which, yeah, I'll put there. That's all right. Okay. Period length. We can put it in the amplitude. Yep, that's right, color. While we're here, amplitude, still 1 times cos, so 1, negative 1. Period length is 2 pi divided by this. Notice that that's a quarter. 2 pi divided by a quarter, you can do your keep change flip thing, whatever it is, but you should end up with 8 pi. So 1 complete cycle up here is 8 pi. Now we can fill in the rest of it. So here would be 4 pi, so this is 2 pi, this is 6 pi, and so on for everything else, as far as you want to go. Great. Alright, well now I want to figure out what these graphs are functions of, what these graphs are pictures of. Okay, well, I'll do this in pink, because I can. So, first thing, amplitude is the easiest thing to read off, so it has to have a 3, multiplying it. Then it could be sine or cos, okay? And then I need an x in here. Actually, let's do this in black. Ooh, black's dying. Okay. Okay, from here, I can go, that's 1 cycle, but I don't know how far that is. Well, I'll have to go and use this 3 pi. Okay, if that's 3 pi, I've got 1, 2, 3, so each of these must be pi. 1 complete cycle happens here, so that's 2 pi. Okay, so the period is 2 pi divided by n, but we know that the period is 2 pi. Well, that means that n must be 1, because 2 pi divided by 1 is pi. So I can have a 1 in here, but the 1 is redundant, so I could just leave it out. That's fine. Last thing is to figure out if we've got sine or cos. This thing starts in the middle, so it's going to be sine. Because sine starts in the middle, cos starts at the extreme. Beautiful. What about this guy? Alright, we've got amplitude, easiest to read, so that's 8 times something. Could be cos or sine, we'll leave that out for now. Cool, something times x. Okay, what's our period length? Well, I've got 7 pi on 4 here. Well, I've got to be a bit more careful now, because I've got to remember that this is a section, this is a section, this is a section. Okay, 1, 2, 3, 4, 5, 6, 7. So each section must be pi on 4. Okay, I want to get from, here's pi on 4, that'd be 2 pi on 4, or pi on 2, 3 pi on 4, up to pi. I've got from here So there is one complete period length. So my period is 2 pi on n equals pi. Okay, therefore n is a half, right? Because 2 divided, 2, what's wrong with me? Oh dear. Sorry, 2 pi divided by 2 would equal a half, so that must be 2. Last bit, figure out if we've got sine or cos. We're starting at a maximum, so it must be cos. Beautiful. So that's how we do that worksheet. Hopefully that makes a little bit of sense. It's easy enough to get a little bit confused, but if you go through things slowly but surely, it's not the worst thing in the world. You've got solutions on there. If you get stuck at all, do email me, and we'll hopefully be able to resolve all your troubles. So that's worksheet 14G. Okay, cheerio.